Hello everyone. Now we are going to understand what will be the effect of resistance, current and potential difference when resistors are connected in parallel. This is the part of your chapter called electricity. Okay. So here we have the combination. See here we have R1, R2 and R3 are the three resistors and they are connected parallel to each other. Okay. So here we have battery or the cell. Here we have the key in order to switch on and switch off the flow of electric current through the circuit. Again, here we have ammeter which is used to measure the current, and here we have voltmeter in order to measure the potential difference. And in order to measure the current across the R1, R2 and R3, here we have three again the ammeter which is used to measure the current. Okay, and see this combination. Okay, from that particular point we have connected all the three resistors parallelly. Okay, so the resistors are said to be connected in parallel when their ends are connected at both the side as shown in the figure. The figure shows that three resistors R1, R2 and R3 are connected in parallel between the point C and D beta. Here we have the point C and here we have the point D, and between point C and D we have connected three resistors parallel to each other. V is the potential difference between C and D. So the potential difference between point C and D will be the V. That means in this combination, potential difference will remain same or constant. So potential difference will remain constant. Let I1, I2 and I3 be the current flowing through the resistance R1, R2 and R3. See here, we had the main wire, then it split into three parts and which is flowing along with the three resistance here. So the current flowing through each resistors will be, I'm just taking for R1 it is I1, for R2 it is I2 and for R3 it is I3. So I1, I2 and I3 respectively. Then the total current flowing through the circuit will be what? So it will be total current. I'm writing here total current flowing through the circuit will be I equals to I1 plus I2 plus I3. Let RP is again the resistance and P represent for the parallel. So the resistance in parallel, the effective resistance between point C and D, again here we have to use the Ohm's law. Therefore, according to Ohm's law, we have, I'm writing here according to Ohm's law. Ohm's law. What is according to the Ohm's law? We have it is V equals to IR. But here we have to calculate I for each resistance. So I'm just transferring that R. So it will be I equals to V divided by RP. Okay, we have I equals to V divided by RP. So current flowing through the first resistance will be what? So I'm writing here current through each resistance. Each resistor. Okay, from each resistor when current is flowing from first it will be I1. So I1 will be what? It is, see, V is the constant beta. So we have to keep V always as the V only. So V equals to R1. For I2 it will be V divided by R2, and for I3 it will be V divided by R3. Okay, so here we have I1, I2 and R3. Now we have to place all the four values here, that one and all I1, I2 and I3 in that particular equation. Okay, so this is the first equation. So we are placing the values of I1, I2 and I3 in first equation. What we will get? So I'm placing I equals to V. So I will be what? It is V. That. So it will be V divided by RP equals to. Now we have beta I1. What is I1? It is V divided by R1. So I'm writing here V divided by R1 plus V divided by R2 plus V divided by R3. Again here we have V common in all the three. So I'm taking V as a common. So it will be V divided by RP equals to V. I am taking common. So it will be 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. So that V and that V will again get cancelled. So now we have 1 divided by Rp equals to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Yes. So here we can conclude that, okay, the effective resistance in parallel, okay, its reciprocal will be the sum of reciprocal of all the individual resistors when they are connected in series. Right, everyone?
Yes, sir.
Yes.
Yes, sir.
So in this combination, potential difference will remain same, but current will decrease. Why current will decrease? Because here the current will flowing along with the three wires connected at the three resistors here, okay, parallelly. That's why current will reduce, but potential difference will remain same. So again, take a screenshot here. We have completed here when resistors are connected in parallel.